Chord Properties number 5. A student questions the teacher. It makes sense that if you have congruent chords, that you would have congruent arcs, but can you prove it? Help the teacher by proving this to be true. So, we're going to go ahead and connect. I don't have a straight edge, so I'm going to use the edge of a piece of paper. We are going to connect C and E, and we're going to connect E to D. We're going to connect E to A, and we're going to connect E to B. Alright, so we can do this 2-column. So statements and reasons. Okay, and our first thing that we were given is CD. Segment CD is congruent to segment AB. Remember that we are trying to prove that arc CD is congruent to arc AB. Okay, so I'm allowed to connect these segments because when back in Unit 1, we've discussed that through 2 points, there's always a straight line. Let me zoom out a little bit. I just realized you couldn't see what I wrote. Okay, so between 2 points, there's a straight line. So we connected CE, connect C to E, D to E, E to B, and E to A. Between, and we didn't have a name for this, so we're going to go ahead and write it out. Between 2 points is a straight line. Now, in respect to the circle, what are those segments called in our circle? Those segments are all radii. Okay. And what do we know about radii? Well, we know that all radii are congruent. So we know CE is congruent to segment ED, is congruent to segment EB, is congruent to segment EA. And that's because all radii are congruent. Okay. Now, if I look at those, I can easily see that this top triangle and this bottom triangle are congruent. So triangle CDE is congruent to triangle. Okay. C corresponds with B, D with A, and E with E. And we know that by, we have a side congruent to a side, another side congruent to another side, and the third set of sides. So this is side, side, side. If the triangles are congruent, their parts are congruent. And angle CED is therefore congruent to angle BEA. So angle CED is congruent to angle BEA. And that's our CPCTC. Corresponding parts of congruent triangles are congruent. And now we have a theorem that says if we have congruent angles, the chords that are, not the chords, the arcs that are created are also congruent. So arc CD is congruent to arc AB. Okay. Congruent angles in a circle, then arcs